Conservation laws only constrain a collision. To calculate the actual deflection, we must know the central potential U, r, and solve the orbit. After reducing the two-body collision to one particle of reduced mass mu, the incoming orbit is described by its speed at infinity v infinity and impact parameter b. The impact parameter b is the perpendicular distance from the incoming line to the force center, giving m equals mu times b times v infinity and e equals 1/2 times mu times v infinity superscript 2. The particle approaches the center, turns at its closest distance r, and escapes. Orbit symmetry connects the incoming and outgoing asymptotes to the scattering angle chi. Different values of b produce different chi. A small impact parameter usually means a closer encounter and larger deflection, while a large b gives almost straight motion. For a uniform beam, particles between b and b plus dB occupy an annulus of area 2 pi times b times dB, defining the cross-section d sigma equals 2 pi times b times dB. Writing b as a function of chi gives d sigma slash d omega equals b slash sin chi times dB slash d chi. This differential cross-section links the measured angular distribution back to the interaction potential.